Today I am going to talk about the topic assignment problems in operation research. To find the assignment problems by using Hungarian algorithm. Here the 3 jobs are assigned to 3 machines. We have to find the minimum processing cost. Here the problem is a balanced assignment problem because it is a 3x3 matrix. So it is a balanced assignment problem. To find the optimum assignment by using Hungarian algorithm, in the step 1, we have to reduce the rows of the values. Row reduction. Find the minimum cost in each row and subtract minimum cost from all other elements of the respective rows. In the first row, minimum value is 19, so we have to subtract 19 in the first row. Then the result is 0, 9, 12. In the second row, the minimum value is 11, so we have to subtract 11 in the second row. The result is 0, 6, 5. In the minimum value in the third column is 12, so we have to subtract 12 in the third row. The result is 0, 3, 1. In the step 2, we have to reduce the columns values. Find the minimum cost in each column and subtract minimum cost from all other elements of the respective columns. In the first column, 0 is the minimum value, so we have to subtract 0. In the second column, 3 is the minimum value, so we have to subtract 3. The result is 630. In the third column, the minimum value is 1, so we have to subtract 1. The result is 1140. Then we have to move on. Step 3. Now we draw the minimum number of horizontal and vertical lines to cover the zeros of the cost matrix. Here I draw 2 lines, one horizontal and one vertical line. The number of lines is 2. The order of the cost matrix is 3x3, so we have take 3. 2 is not equal to 3, therefore the optimality is not obtained. So we move on to step 4. Choose the least cost element in the cost matrix, which is 3. Subtract 3 from the elements which are not covered by the lines and add 3 to the elements lying in the intersection of the lines. Then again we draw the minimum number of horizontal and vertical lines. Here 3 is the minimum value, so subtract 3 which are not covered by the lines, and intersection part we have to add 3. The remaining parts the same values in the table. The result is 038, 001, 300. Then again we draw the minimum number of horizontal and vertical lines. Here the lines are 3. The order of the matrix is also 3. Therefore 3 equal to 3, the optimality is obtained. Then we move on to step 5. Select the zeros of the above cost matrix. We have to highlight the zeros and select the zeros. Here one condition is apply. What is the condition? One row and one column only have 1 zeros. In the concept, I choose in the first row first 0, then I eliminate in the first column of second 0. Then I take the job 2 and machine 2 0, then I eliminate second column of the next 0. In the last job only 1 0, so I have to choose that 0. Then each column and each row only have 1 zeros. Then we have to add these zeros of the given cost matrix value. The optimum assignment is job 1 to M1 and job 2 to M2 and job 3 to M3. The minimum processing cost is in the first table, given table, we have to choose the values of the zeros. So J1 to M1 is 19, J2 to M2 is 17 and J3 to M3 is 13. The total cost is 49. This is the minimum processing cost for the given assignment problem. Thank you.